Hello everyone. Welcome to our first ever math class of this year. Um, we'll be starting today with a Kahoot, which I know is not typical, but I just kind of want to see how everyone's math skills, whether they're all up to date, and just want to check if we already know most of these concepts. So if you guys can all type in the KPIN to your Kahoot, we can get started in about 2 or 3 minutes. All right. Post the link in the chat and
What? About join?
yeah, I see some familiar faces. I appreciate Ryan,
Or
Ray.
do I have to join?
Yes, I'd appreciate if you can join the Kahoot, Jason.
Can you post a link in the chat?
Yes, it is in the chat. I'll post it again. Can you see it now, Jason?
Wait, wait for it. I'm trying to get in.
All right.
It's
So
still loading.
I see. Yeah. I appreciate that we have Ryan, Rochelle, Scene, Ray. You guys all have your cameras on, so that's very nice of you guys. I'd appreciate if you do have a camera to turn it on as well, so that this class is more interactive. All right. Is everyone in? Do I need to wait for anybody? Um,
Me.
no. I shall begin. This is just the first 10 questions are going to be a review.
Wait, I'm not done. Almost finished.
I'll wait for you for one more minute, Jason. So for the Kahoot that we're starting with today, it's just going to be a review of concepts I think you guys should have learned either in grade 3 or grade 4. So if you don't know any of these, don't worry. We'll be covering some of them. And after we're done the Kahoot, I'll be introducing a new concept which if some of you guys have taken my Math Kangaroo class should be familiar. It's the proof by contradiction. I'll be teaching how to use that, especially in competition questions. All right. So I think we have somebody in. I believe everyone is in. So let's start the Kahoot. All right. So the first round, we're just going to be doing a concept round, just review of basic concepts. Here we go. All double points, by the way. All right. All right. So we have two people who have answered that you cannot divide by 0, which the answer is going to be it's actually very complicated to explain, but when you divide by if you divide any number by 0, the math just starts getting very messy. Even if you say, let's say 1 divided by 0 is equal to 0, if you bring the 0 over, then you get, for example, okay, I'll write it out. Um, I see lots of people, they all said the answer is always going to be 0. So let's assume that 1 divided by 0 is equal to 0, okay? So this is actually a very good example of using proof by contradiction. So we first assume that this is true, all right? And if this is true, then we can multiply a 0 over here. So this becomes 1 equals 0 times 0. Okay, and does everyone know what 0 times 0 is equal to?
0.
You can type in the chat or unmute yourself. Yes, Nancy says it is 0. Thank you, Ethan. So we know that 0 times any number is 0, right? So if 0 times 0 is 0, but we have 1 equals 0 times 0, then we get the weird statement that 1 is equal to 0. So does that make any sense? Does 1 equal 0? No. Thank you, Nancy. So I mean, you can replace this 1 with any number. If you threw in a 2, for example, I know black is a bit hard to see. So if you threw in a 2 divided by 0, and you also said that's equal to 0, then if you bring it over, then you get something like 2 is equal to 0 times 0. And we know that 0 times 0 is equal to 0. So now we have this weird statement that 1 is equal to 0 is equal to 2. And we all know that's not true. That's not how numbers work. So when it comes to dividing by 0, we just label it as undefined. There's just no answer that we can put in here, so the answer here is just going to be undefined. It's very unsatisfying, I know. I was actually very frustrated by this concept myself, but it's just something you gotta live with. All right, let's move on to the next question. So, okay, this one's also double points. What value does the 2 represent in this number? Okay, moving on. I'll skip it. Okay, I see most of us have chosen 0.02, which is correct. As you can see, the 2, it's shifted 2 decimal places to the right. So before it was a 2, then it became 0.2, and then it became 0.02. I'm glad that most everyone got this right. There's an 8 before it, so it's not just 0.2, it's a 0.02. All right, looking nice. It's a probability question. Nice. I suppose I don't need to explain it then. Everyone knows that rolling a 1 on the die is just 1 over 6. It's the same with any other number, 2 over 6, 3 over 6, and, well, anything between 1 and 6 is just 1 over 6, because there are 6 faces to the die. Let's move on. Okay, what is the mean of a bunch of numbers? I know mean can mean something else. It can actually mean two different things. But in terms of numbers, what does it mean? Okay. Okay. Let's see. We have, I believe 5 people got this correct. For those who chose for those who chose yellow and green, um, you'll see later that yellow and green, they mean something different. But a mean, it's usually just an average. If you take all the numbers, you add them up. For example, let's say I have 1, 2, and 3. Okay, I want to find the mean of these numbers. So to find the mean, I would take 1, I would add it to 2, 1 plus 2 plus 3. So can everyone tell me what 1 plus 2 plus 3 is? So 1 plus 2 plus 3 is equal to 6, correct? And once we find 6, the mean of a bunch of numbers is finding the average. And if we count, there are 3 numbers here, right? You can see there's one number, this is the second number, this is the third number. So to find the mean, we would then need to take 6 and divide it by 3. So what's 6 divided by 3? Ryan, can you tell me what 6 divided by 3 is? Or Ray, can you tell me what 6 divided by 3 is? You can unmute or type in the chat.
Still thinking, still thinking. Wait, did you say 6 divided by 3?
Correct.
2.
2. It is indeed 2, because 2 times 3 is 6, so 6 divided by 3 is 2. You can bring them, you can interchange them. So yes, thank you, Rochelle. 6 divided by 3 is equal to 2. So in this case, the mean of these three numbers is 2. I calculated the arithmetic mean over here. It's a pretty complicated term, but for now, I'm pretty sure the mean you guys currently know is just adding all the numbers together and then counting how many numbers there are. You see there are 3 numbers in the group, and then dividing by that number. Okay? So do you guys understand the concept of mean? Would you like me to give another example? Uh, yes or no? So let's say I added a 6 to this. Oh, wait, maybe not a 6. Yeah, let's say I added a 6 to this group. So instead of 1 plus 2 plus 3, I added a 6. So what's 6 plus 1 plus 2 plus 3? Can someone tell me the answer, please? Okay, Nancy put 12. Thank you. So 6 plus 1 plus 2 plus 3 is equal to 12. Um, and then what's my next step if I have all these numbers? 6 plus 1 plus 2 plus 3. I need to count how many numbers there are. So how many numbers are there in this group? Okay, she's already skipped to the end, but we see that there are 4 numbers, right? 1, 2, 3, and 6. Those are 4 numbers. And then if we divide 12 by 4, we divide 12 by 4, I shall also divide this entire thing by 4. Nancy did put 12 divided by 4 is equal to 3. So thank you both, Rochelle and Nancy. So the mean of 1, 2, 3, and 6 is 3. So the mean of these numbers would be 3. Okay, let's move on to the next question. Okay, good job, CC, and high five and ED. Okay, this is also a question that's very similar to the one I was asked before. Probably a bit harder, actually. Okay, I see most people did get this one correct as well. It is indeed the middle number of a list. It's not the number that appears the most often. I think someone's confusing that with the next question, really. But let's say I took 1, 2, 3, and 6 again. Oh, actually, let's just take 1, 2, and 3. And I put this list in increasing order. And what's the middle number in this list? Can someone tell me what the middle number is? So, Kevin, correct. So the middle number is indeed 3. What if I made the list bigger? What if say I put 1, 2, 3, 5, 8, 9, 10? Well, what's the middle number here? 5, correct. So if we count from both sides, we see that if we see 5, it goes 1, 2, 3, and also goes 1, 2, 3. So it's perfectly in the middle. So thanks both Efan, Rochelle, and Kevin. 5 is indeed the middle number of this group. But there comes a question though. What if it's not an odd number of numbers, right? You see there are 7 numbers. Last time I think it was 3 numbers. What if, let's say I threw in 11? What's the middle number in this group of numbers?
It's 6, 15.
Or what are the middle numbers? There are actually 2 middle numbers. Correct. So Nancy, she did say 5 and 8. Those are the 2 middle numbers of this list. So I've seen some people who just list both 5 and 8 as the median, but other times when you just want the median to be a single number, you just find the average of 5 and 8. So if you remember the average, we would take 5, okay? We add that to 8, so, and then divide it by 2. Okay, because there are 2 numbers, 5, 8, that's 2 numbers. We add them together, and then we divide their sum by 2. So Nancy, she just did the math. 5 plus 8. Can someone tell me what 5 plus 8 is real quick? Jason, can you tell me what 5 plus 8 is? Okay, Kevin put 13. Thank you, Kevin. And then after dividing that by 2, what do you get? Have you guys learned fractions, decimals? You can express it in any way. This is already a fraction, really, but can you express it in the decimal, please? So Rochelle, you put 16R1. It's not 6R1. Okay, so it is indeed equal to 6R1. But if you just like your numbers to be integers, that's fine, right? You can just express it as 6, and then you take remainder 1 over 2. That's another way you can express it, right? But if you want to express into decimals, you can do what Nancy did, because if you know that 1 divided by 2, that's equal to 0.5, right? So if you add 6 plus 0.5, this would be 6.5. Yes, Kevin? So 6 plus 1/2 is equal to 6.5. So the median of these numbers, if you wanted it to be a single number, it would be 6.5. Shall we move on, or do I need to explain anything more? Okay. If I don't get any response, I will move on. Okay, leader report is looking nice. Keep it up. Okay, what is the mode of a sorted group of numbers? This is also a statistics related problem. All right, and I see we it is in the mode is the number that appears most often. I'm not too sure why people chose blue, because I just spent some time explaining that blue was like the median. But the mode, it's basically if you take a bunch of numbers, such as 1, 1, 1, 2, 3, 4, and it's the number that appears the most often, right? If you look at the number of ones, right, 1 appears 3 times. So we see that 1 appears 3 times. 2 only appears once, 3 only appears once, and 4 only appears once. So uh, I'm pretty sure mode is probably the easiest one to find if I give you a really, really big series of numbers. You just need to count how many times a particular number appears. So would anyone like to give me another series of numbers and try finding them their mode? Kevin, how about you give me 6 numbers? 6 random numbers. I'm basically using you as a random number generator. Uh, okay. 1, 2, 5, 5, 5, 3. Okay, that works. So can you tell me how many times 1 occurs? 1 appears once, yes. What about 2? How many times does 2 appear? Once, 3, once, and 5. 3 times, correct. So what if instead you put, let's say, instead of 1, 2, 5, 5, 5, 3, I just put 1, 2, 3, 4, 5, 6. And I asked you to find what's the mode of this sort of group of numbers? It's kind of a trick question, really. But if you look at the definition is the number that appears the most often. And we see that 1, 2, 3, 4, 5, 6, they all appear once. So if a teacher is like, hey, I'm giving you 1, 2, 3, 4, 5, 6, tell me the mode. Well, then you're just gonna have to tell them that all 1, 2, 3, 4, 5, 6, all those numbers, they're the mode because they all appear once. So they're the ones that appear the most often, right? You don't have any numbers that appear twice or anything larger. So every single number in this list is a mode. Okay? Does everyone sort of understand the concept for what a mode is? I think this is the last statistics related question. So maybe I might be wrong, but we'll see what's next. I'll clear the screen. Patterns. Have you guys all learned how to identify patterns yet? Or is this anything new? Okay, I think most of us understand how this one works. You can actually, if you look at the numbers, you should be able to identify a pattern, right? From 1 to 2, if you just look at those two numbers,
Just
just
times, just times by 2.
exactly, it is multiplied by 2. So if you start at 1, you hop to 2, you need to multiply that by 2. What if you jump from 2 to 4? How many times do you need to multiply that by? Also, Jason?
Yes.
Yes? Well, from 2 to 4, what do you need to multiply that by? From
2.
2? What about 4 to 8? What number do you need to multiply 4 by?
What? 2.
Also 2, right? So we see it's always multiplied by 2, multiplied by 2, multiplied by 2. And then after 16, once you multiply that by 2, what do you get?
16, and then plus a 32, then you get 64, and
Right.
so on.
So after you multiply 16 by 2, you get 32. And
Or
after that,
one,
you
and
get
then you get
64.
128. You get
Mhm.
128 next after
Okay.
64.
And then what's after 128? Can someone tell me what's after 128?
It goes 256.
256? Can someone other than Jason tell me what's after
Oh
256?
man,
Oh man, it does start getting harder once it starts getting near the 1000
it's
range.
like, uh, can I
It
say it?
goes it goes up really, really, really fast.
Can I go?
It-
Can I say it?
okay, go ahead.
512.
512 after that.
Wait, what? You're asking me now?
Oh, sure.
Okay. 1024.
1024.
Uh,
And after that,
wait. 2048.
2048. And can you go even higher?
4096.
4096. And usually this is when I start going up.
3192. I'm using Google right now.
1192. Oh, okay. All right. That's all right. So
I
uh,
mean, from the 4096 times 2. I don't know what is it.
you don't know what that would be after that? Uh,
No.
but usually it would be good to memorize it all the way to 1024. That's
And
usually
I can only
that would
memorize
be
it all the way to 4096.
4096. That is very nice. I
What's
just based on my experience, I don't try memorizing this pattern. It's very useful, really, but because in computer science and stuff, you need to know binary, so this is a very useful pattern to know. But you just need to know it by experience, really. So I think most people we all found that it's multiplied by two, and it's not adding by any numbers. So in I think grade 11 or something, you start learning things like these. They're called geometric series, right? So between every term, you always need to multiply by some number. And as we saw, it's all multiplied by 2. It doesn't always need to be multiplied by 2. You can multiply by 3, multiply by 4. You can even multiply by -1. -1, the pattern gets really weird for -1. It just bounces between 1, -1, 1, -1. So just identifying these patterns, it's a very nice skill to have. All right. Wow, we have someone in the 10,000 range. Right, question 9. See what this one is. Ooh, what kind of triangle is this? You have to look at the picture. These are all some very fancy terms. I see most people know that equilateral would be a triangle with all three sides that are equal. I'm guessing that the people who guessed red and yellow are probably guessed. But if you don't know what a scaling triangle is, it's basically the most commonly drawn triangle, which is you just randomly draw three sides. Okay, that was a bit too well drawn. But a scaling triangle is you just randomly draw three sides and none of the sides are equal, right? This side, it's not equal to this side, it's not equal to this side. An obtuse triangle is a triangle with like, it's flat.
more than
That's all it
90
is.
degrees?
Yes, this angle is more than 90 degrees. Who said that?
Wait, can I say something?
Go ahead.
isosceles is like two angles that are same, but then one of them are wrong.
Okay, that terminology, it's a bit inaccurate, but yes, two angles are the same, two sides are the same, but one angle is different. It doesn't
That's
always
what I was
be
trying to
different.
say.
Yes, so these two angles would be the same. This one is a bit different, like this one at the top.
Oh yes, it just makes your scaling for the scaling thingy, everything's wrong, right?
Well, the sides are
Everything,
all the sides don't match.
yeah,
That's
okay.
they're not the same. Obtuse triangles, if you look at the biggest angle, remember for obtuse angles, you always need to look at the biggest angle. Like triangles, when we classify them, we always look at the biggest angle. We don't go like, oh look, this is teeny little angle over here. We don't look at the tiniest angles. We always look for the biggest angle. And if the biggest angle is really big, like fat, then we know it's an obtuse triangle. And later, I think next question, you'll see if the angle is right, then it's 90 degrees. That's a right triangle. They're very special. You use them a lot in geometry. But if all three
But then
angles,
which one is the right triangle?
right triangles, we'll see. Let's look at the next question. All right, let's move on. If I can get my mouse to work. Wow, 12,000. Is this a right triangle? Well, let's see if you can tell if this is a right triangle or not. Pretty standard. Um,
We.
Yeah, I'm skipping. You should be choosing pretty quickly. I believe everyone did get that right. It is a right triangle because that square, if you looked at the picture properly, there is a square. There was a square here that indicated it's a 90-degree angle, right? And the other answers, they're all messed up, really. They're just puns on the word right, but I'm pretty sure everyone here can identify what a right triangle is, so I'm not going to stay too long on it. Let's move on. I believe we have one more question. Okay, now we're entering the realm of 3D shapes. What is this 3D shape?
I pressed it wrong.
Uh-oh.
It's a
Well, okay. How do you know you pressed it wrong?
or what? I got it right.
You got it right. So
I thought it was a
who said-
triangular prism.
Oh, you thought it was a triangular prism. I think someone else also thought it was a triangular prism. I'm just going to draw most of these shapes out for you. I think everyone who did choose red knows how a triangular pyramid note looks. A cube is also pretty standard. It's just all three sides are equal. Well, not all three sides. Like all three lengths are equal, and if it just made up of squares, right? And there's like the dotted lines in the back. This is what a cube looks like. It's not exactly an Egyptian pyramid either. If you've ever seen an Egyptian pyramid, they all have square bases, or if it's not square, it has to be some kind of rectangular base, right? So pyramids, they all look somewhat like this. This is what an Egyptian pyramid somewhat looks like. But a triangular prism, I always think of prisms like this. Let's say you take any shape, okay? So in this case, we're taking a triangle, and then you pull it up. You take the triangle, you go wee, you just pull it out long, and then that's how you get the prism. So in the back, you have this dotted line.
It's
And here you have a
6:30.
triangle. So in this case, this is a triangular prism. You also have rectangular prisms or square prisms, but in this case, it's a rectangular prism. You also take the rectangle, you pull it up, and you also get a prism. So in this case, the rectangular prism looks almost like a cube. Given my bad art skills, but this is also a prism. You can, it doesn't need to be a rectangle or a square. You can make it a circle, which would be a cylinder, but you can also make it something like a pentagonal prism. So you can take a pentagon and, take the same operation, go like, whee, pull it out long, and then you have this really, really nice pentagonal prism thingy. Over here, you connect all five sides. It's starting to look a bit ugly, but yeah, you can do the same with a pentagon, with a hexagon, with any gun. You can even take a star, for example, pull it out long and you get a star prism, I guess. Is that what it's called? But you can take any shape, pull it out long, and you get a prism. So that's basically what prisms are. If you weren't too sure what they really are. I think this is the last question for our review. Yes, that is the last question for our review. And would anyone like me to go over anything else before I start with class for today?
So we finished.
We're only at 6:30. 6:30.
I'm in the Kahoot.
Oh, we still have a bit more for the Kahoot. We have 10 speed round questions, but that's for about 6:50-ish. So you still have 20 minutes of class. All right. So for today, oops, I'm going to need to get rid of this. For today, I'm going to be introducing something called proof by contradiction. And Jason, do you mind being my partner
Okay.
or my friend? Because something about friends is that friends always like to argue. Well, not always, but friends have a
I
tendency
like to argue with my
to like.
friends.
Okay, so Jason is a prime example here. Jason, you say you like to argue with your friends, and let's let's say your friend. Do you play chess or any sort of game?
Yeah.
Okay, let's say you play chess. And your friend plays chess too, and your friend's like, "Hey, Jason, I am the best chess player in the world."
Sure. I don't care.
Okay, and then you, of course, are you going to argue against him about that?
Yeah. I
Yeah.
debate.
Okay, you're going to debate. And if you just go like, I'm the best player. No, you're not. I'm the best player. No, you're not. Yeah, are you gonna get anywhere with that? Not
No.
really,
Well, it
right?
could only if one of us give up.
Yes, only if one of you give up, or if you actually, sat down to a chess match with him and beat him in a chess match, right?
Yeah.
Yeah. So let's say you sit down to a chess match and you beat him in a chess match.
Easy.
Then can he go around and saying like, I am the best player in the world?
I'm sure to people he's better at.
Okay, well, to be fair, if you beat him in a chess match, he cannot go around saying, I am the best player in the world because you beat him in a chess match, right?
Yeah. Pretty much.
Yes. So that would be proof by contradiction. If, let's say, someone says a statement and you can't exactly prove that that's false, but if you disprove that statement, then you know that that statement is false. That's proof by contradiction. I don't think I worded
You'll
that.
just get embarrassed when you
Yeah, he will get embarrassed for one, but you also prove by contradiction that he is not the best chess player in the world.
nor am I.
Well, we'll have to see about that.
Am I?
But that's the basic concept for today. Uh,
I'm only the
let's start with an
best.
example. Yes, Jason?
I'm only the best in my grade, not the whole world.
Okay. Well, that's still an impressive feat. Um, I'm going to need you to do something else, Jason. Um,
Okay.
I'm going to think of a number, and you're going to try and guess of that number. Okay? So I'm going to call my number X. All right? And I'm telling you that these are the conditions. X is greater than or equal. Oh, so sorry, less than or equal to 5. And let's see, greater than or equal to 0. Okay, this is the first condition. Now I'm
So
gonna
it's basically 0 to 5.
yes, so between 0 and 5, my number is somewhere there. Next, I'm going to say, so if I asked you to guess that number, you could spend a million years and well, maybe not a million years, but you could spend a long time and you still couldn't guess that number, right? Because there are infinite numbers between 0 and 5. Okay? Right,
Like
Jason? So it would
2.1.
take you very hard, it would be very hard for you to guess that number.
But can we just like 1.0.1, 0.2, 0.3,
Okay,
0.4,
but
0.
what if I my number was chosen like 0.001? You would never get that number, right? Because you first you'd say 0.1 and then you go all the way to 5 and you would still miss the number. So that's not a very
Now
good.
start at 0.001.
Okay, but it would still take a very, very long time. And you'd be better off. You'd be better off if you just asked me, give me another condition, right?
Give me a hint.
Yeah,
boy.
give you a hint. Okay, so I'm going to give you another hint. I'm going to say that my x is now smaller than or equal to 3 and greater than or equal to 2.5. Okay?
Now that's easy. I
Now,
know.
okay, maybe that is a bit easier, but still really hard, really. Because between 0.5, 2.5, and 3, there are still infinite
It
numbers.
could be 2.538538.
Okay, sure. Yeah, it could be some really weird number, right?
But can I ask, can you give me the answer?
I'm just going to give you another hint. So
Oh
now,
man.
now, if I told you that this x is greater than or equal to 2.5, this is smaller than or equal to 2.5, but greater than or equal to 2, could you tell me what x I'm thinking of right now?
2.2?
2.2. Well, is 2.2 between 2.5 and 3?
Yeah.
Are you
I
sure?
mean, no. 2
No,
point,
no, it's not between
let's
that.
see. So it's lesser than, wait, it's more than 2.5 or lesser?
Well, it's for this condition over here, it's greater than or equal to 2.5. But for this condition over here, it's less than or equal to 2.5.
So it's 2.5.
Ah, but why is it 2.5?
Because if it's more than 2, you said it's more than 2.5, then now you said it's lesser than 2.5.
Less than or equal to 2.5.
But then how could that be if it's greater and lesser?
Well, I did
So we
put
can only
greater
be
than or equal
equal.
to. Yes, it can only be equal to. Let's say your boastful chess master friend comes in again and says like, hey, why can't it be 2.2? Like you just said. Why can't it be 2.2? Why can't x be
Because it
2.2?
could. Because yes. Yes. Because yes.
Because yes. Can you mathematically prove why it has to be 2.5?
Um, kind of.
Kind of? Okay.
No.
Would anyone like to help Jason out here?
No.
Do I have any volunteers? Rochelle? Would you like to give it a guess?
Wait, I can't, right? Or I could.
Well, you can prove it if you want to.
But I mean, like 2.2. 2.5 can be 2.2 though.
So
I'm,
it,
I
it
mean, it could in 0 point under 0. I mean, 0 to 5. It could, but then not 2.5 now.
right. So let's assume that 2.5 was not my answer. Okay, let's just pretend that 2.5 is not my answer. It's some
You lie.
yeah, I lied. So if we assume that 2.5 is not my answer, let's say it's some value of y. All right. So it's not 2.5. It's some other value. It's some non 2.5 answer. And this y is just not 2.5. If y isn't 2.5, then it has to satisfy both of these conditions, right? Correct? Because we know
Yeah.
y has it's the number I'm thinking of, so y is equal to x. So
Y
if
equals
y,
to X because
yes,
A, B, C, D, E, F, G, H, I, and never mind.
no. So x is just the number I'm thinking of, and I just tell you I didn't think of 2.5. Okay?
So you're basically telling me that the answer is trying to, I don't know how to put this,
Right.
but
So
like Y
so
equals 6.
if we pretend that the answer is not 2.5, okay, we're just pretending the answer is not 2.5 because the actual answer
Oh,
is 2.5. But we're just pretending it's not 2.5 for this lesson. And if it's not 2.5, then we know it has to satisfy both that it's between 3, it's smaller than or equal to 3, or greater than or equal to 2.5, right? It can be, for example, 2.5000000001, something like that, right? That's a valid it's a valid answer for y. Or it can be something like 2.9999999999999, something like that, right? So these are like the answers that y can be equal to. But if y is one of these answers, so let me just draw a number line here. So we know it can't be equal to 2.5. This is 2.5.
that is the middle.
Yes, that is exactly the middle. We assume this is 2 and this is 3. So first, let's assume that y is bigger than 2.5 because it's not equal to 2.5. It has to be either bigger or smaller, right?
Wait, can you repeat? I didn't hear.
So first we assume that y is not 2.5.
Yeah.
Yeah. So if
Yeah.
it's not 2.5, it has to be either on this side or it has to be on this side, right? It has
Not
to be on either side.
necessarily.
Well, then which side can it be on?
You didn't say it has to be 3.
Well, it doesn't have to be 3, but it can be between 2.5 and 3, or it can be between 2.5 and 2, right?
Hmm.
So let's just this is something else I'm going to teach in the next lesson. We're going to have to split this into two cases, right? The first case is just going to be we assume that this y, I'm going to make some space here. This y is greater than 2.5. Okay? So if y is greater than 2.5, we assume that y is greater than 2.5, then what happens to this condition? What happens to condition number 2 here? Does y satisfy this condition?
Maybe. Wait, yeah.
Why not? Well, why so?
Wait,
Well,
can
we
you
see that
repeat?
y is greater than 2.5, right?
It could be 2 or greater.
Well, this is our first case. We assume that y is greater than 2.5. This is case number 1.
Okay.
Okay.
Happy.
So if y is greater than 2.5, is it smaller than 2.5?
No.
No, that's the weirdest statement that ever came out of my mouth, right? So if it's greater than 2.5, it's not smaller than 2.5. So we know that y cannot be greater than 2.5, right? So we know that this is not a good case. So if that's not the case, then we can assume that y is less than 2.5, right? So if y is less than 2.5, y is less than 2.5, is y greater than 2.5?
No.
No, that's also another really weird statement that came out of my mouth, because if y is less than 2.5, it cannot be greater than 2.
Wait, if it's the weird thing that ever came out of your mouth, why did you say it in the first place?
I'm not sure. But so we know that if y is greater than 2.5, it can't be smaller than 2.5. But if it's smaller than or equal to 2.5, it can't be greater than 2.5, which means in this case, y has to be equal to 2.5, right? For both of these statements to be true. Correct? Otherwise, no other answer would work.
Yeah.
Yes? So any other answer, any other x we throw in here would not work. Do you guys sort of understand where I'm going with this?
Yeah.
Yeah, I think it got a little bit got a little bit complicated. But I'm going to take so starting from here, I'm going to take a question from the 2021 grade 5 to 6 math kangaroo. I don't think you guys have seen this one before, but it goes like this. Do I have any volunteers who would like to read question 26, please? Ryan, could you read question 26? This text highlight over here.
An apple and an orange weight as much as a pear, and a peach. An apple and a pear weighs less than an orange and a pear, and a peach and an orange weighs less than an apple and a peach. Peach. Which fruit is the heaviest?
Okay, this sounds very complicated, and if we just stare at the text, it's not going to help very much, right? I mean, it's just text.
It's
They don't give you any images. They don't
6:45.
give you nothing. So in this case, we're going to have to label some of this stuff ourselves. All right. So I'm going to move out of this. Move. Oops. Okay. Yeah, let's go over here. So let's denote A for apple, right? Because A is for apple. That's what it always has. It always has been. This is apple. And then I think we had an orange, right? So let's use O for orange. Oops. O for orange. Okay, so O is going to be for orange. Pear and peach.
E
I'm
for
just going
peach.
to. Well, they both have an E.
E for
I'm
peach.
just gonna put R for pear. Is gonna be for
Why
pear.
can't you just put PE for peach? And then P. Oh, never mind.
Right. They both start with like the same three letters. And then for peach, I'm just gonna put C because I think it's the only one with a C in it. So let's look by the
Arak.
that this is just going to be our notation for this question. We see that an apple and an orange, they weigh as much as a pear and a peach, right? Is that correct? So an apple and an orange, what this notation basically stands for is that
Apple and orange and
so apple plus orange, it weighs as much as a pear and a peach. So it's the same as R plus C, whatever they weigh. This is our first equation.
so if we figured out one, we can figure out the other one.
If you figure out three, you can figure out the last one. But we're not given any numbers here, right? Do you see any numbers on this question?
An apple and a pear weigh less than an orange and a peach. What?
Okay, yes. So there are actually no numbers in here. The only thing we can use are inequalities. So inequalities, as we just saw, were the things I've been using here, these alligator mouths. So the second piece of information we're given here is that an apple and a pear weigh less than an orange and a peach. So we can write here that an apple and a pear is is R, so A plus R is less than an orange and a peach, O plus C. So do you guys notice anything interesting about these two equations before I write the third one down? Ray, can you tell me anything interesting about equation 1 and equation 2? So like if you look at these two variables, for example.
They both have C in the end.
Yes, they both have C's at the end. What about at the beginning? What do they have at the
They
beginning?
both have A's.
They both have A's at the beginning. And what else do you notice about O's and R's? What happened to the O's and R's?
They just swap places.
Yes, they swapped places. So if they swap places, what can you tell about that?
Nothing. Yes.
Nothing really. Let's say we took okay. Well, we're going to have to manipulate equation 1 a little bit. So for equation 1, we can try taking away a pear and we can take away an orange, right? Because the apples and the
Wait.
mhm.
So basically, wait, can you go back to the question?
Okay, the question or the equation? These
Not
are
the question. I
question?
have no idea what you're scribbling down.
Okay. And so far I put the first sentence in, right? And I also put the second sentence in. So an apple and a pear weigh less than an orange and a peach. And finally, we have the third sentence, which is a pear and an orange weigh less than an apple and a peach. All right. So I'll write the third sentence down. A pear and an orange, a pear and an orange. These two weigh less than an apple and a peach. So this is equation number 3. And I believe the question is asking which fruit is the heaviest. Yes, that is the fruit that is the heaviest. And obviously, if you just stare at the question like this, you're just going to pick E because it's very hard to find out which fruit is heavier when all you get is a bunch of text, right? But I'm just going to tell you right away that it's not E. You can figure it out, and let's give it a try. So over here, I think Jason, you already noticed that both there's an A on one side and there's a C on the other, right? And
Wait, and R and O are supposed to be in with each other.
pardon?
R and O supposed so RO is greater than A and C.
So you think that R plus O is greater than A and C?
Wait, is that right though?
A pear and an orange weigh less than an apple.
Oh,
So it's still this way. The alligator mouth is still going to eat the apple and the peaches instead of the pears and the orange. You can actually find something else out right away very easily. Is that C is always on this side, right? It's always either equal to those two or it's always on the greater side,
yeah.
right? So if you were to guess, which fruit would you guess would be the heaviest?
Pretty sure not C.
Why not C?
Wait, C would be in the greater because C is always on the greater side.
Right, so it does feel like the peach is always on the greater side. So if we were to guess, you would choose C right away. In a competition, if you just stare at an equation like this and you're really, really short on time, you can just go ahead, choose C and choose peaches and be done with it. But for us, we're going to try and prove this strictly, okay? So let's pretend we don't have equation 3 right now. We're just going to look at equations 1 and 2, okay? And as Jason noted, that there's an apple on the left side and a peach on the right side. And the only order that's changed is the orange and the pear, right? So let's try bringing the pear to this side and the orange to the other side and see what happens. So if I take equation 1 and I subtract an orange and I subtract the pear, so before it's apple plus orange, right? If I subtract an orange and I subtract a pear, this is the same as taking a pear and a peach, subtracting an orange and subtracting a pear. They're the same things. I can probably rewrite this a little better. So this is equation 1, right? Apple plus orange is equal to pear plus peach. You guys all see that,
Yeah.
right? If I get rid of an orange on each side, so I take away an orange, and I take it away an orange on this side. What happens to the left side? If I add an orange, I take away an orange, what happens to orange?
Wait, so only wait. Yeah, only weighs more than R.
I can't hear you very clearly, Jason.
O weighs more than R.
Okay, so you think O weighs more than R, but
Yeah, because if you O and R are similar. Wait, O is heavier than R. Wait, what? Wait, can I say again? R. I mean, O is heavier than R. Is what I mean.
well, we like to prove this mathematically.
Yeah.
So
Why can't you just say because if you swapped it if it was even with
swapped-
O.
right, so if you swap them, because apples and peaches, if you just keep them on each side, you swap them, you see that the orange suddenly it weighs down heavier. So I like the fact that he's already exploited this fact that an orange is heavier than a pear, right? So we know this already. We know that pears can't be the heaviest because there's already a heavier orange. So if you were to choose an answer, we would not choose a pear. So pear is not the heaviest. We know that orange might be, but let's see if we can do anything else.
And for this third equation,
For the
R
third
plus
equation,
O is still it will be lesser than A.
actually,
So
I like what you did. I like what you did, Jason.
so
So
that
you know
means
how for
O.
1 and 2, we had O, we had A and C, both of them were equal, right? They were on the same side, but then R and O switched.
But then when
What
you
if we
did
looked at 1 and 3? What if we looked at 1 and 3? We see that O is still on the same side of the equation. C is also on the same side of the equation.
but A.
But A is
No,
over
wait,
here. So now what do we know about A? Here, let me write it over here. So A plus O is equal to R plus C. This was equation 1. But over here, we have R plus O is less than A plus C.
wait, so is R heavier than A?
Well, if you looked at this one, before it was balanced, right? But then you swapped them around, and then now the apple it's heavier. So what do we know about A and R? So who's heavier?
A.
A is heavier, exactly. So we also know that an apple is heavier than the pear. Okay, that's very nice and all, but we still don't know whether the apple's heaviest, the
No,
orange.
C is
or whether-
heaviest.
Why would C be the heaviest?
Yeah, remember A plus R?
Mm-hmm.
F O and R. F O and R switched. The O we know that R weighs more than R,
Mm-hmm.
and the O weighs lesser, right?
The O weighs more than R.
Yeah, and so doesn't the R weighs lesser, and so if we take away the A needs more to be like he needs more support to be as much as C, but C doesn't need that much. He only needs the R because it's not that heavy.
That does make very much sense. But we can actually prove something else here. If we take equation 1 and we took away an orange on each side, okay? So on the left side, what's A plus O minus O?
A plus O minus O.
So
A.
plus O minus O, yes, it's just an A. These O's cancel. What if we took away another R, right? Because we have A's and C's. We just want to keep the A's and C's. What if we took
C will be heavier.
So I know on the left side it's just going to be A minus R, right?
How is C very heavy? How is peach
C-
very heavy? In real life, an apple should weigh more than a peach.
Well, it could be very small apples. I've seen big apples, very small apples. We don't know how heavy the apples actually are.
Gigantic apples that weighs 10 pounds.
Okay, well, if we look on the right side, what's R minus R?
R minus R equals R. I mean, just no, 0.
There's 0. So these R's cancel. We would have A minus R is equal to C minus O. So if we took an apple, we took away the R. It's the same as if we take a peach and we took away the orange, right? And what we know here is that this is basically another variant of equation 1. But we also have equation 2, right? If we take equation 2, it says that A plus R is smaller than C plus O or O plus C, right? What if we add these two equations together? What happens?
The what?
So if you look at these two equations, what if we add them together?
A plus R is good. Wait. So you told me to add both of the equations?
Yes, add both of the equations together.
A minus R equals A and C minus O equals C. And the A plus the R equals AR. It means it's back on this regular.
Actually, so when we add two equations together, we usually keep the inequality sign, okay? So the inequality sign is still kept. But for example, the A's and the A's, what happens when two A's are added together?
A.
2A, right? So it's the same as you take 1, you take 1. What's 1 plus 1?
2.
2. So it's the same with A. You take A, you get another A. What's that?
So 1A plus a 1A equals 2A, and plus
2A.
another A is 3A.
Right, if you keep on adding A's, you get 4A, 5A, 6A, but in this case, it's just A plus A.
That would be nice.
Plus A is 2A. What happens with plus R minus R?
So it would just be a normal R.
Oh no, there's no R's. So the R's disappear.
Wait,
What about the right side? Someone other than Jason. Ryan, can you tell me what C plus C is?
C. What?
C plus C. So before Jason did A plus A is 2A, so C plus C is 2 what? 2C, correct. And what about positive O plus negative O?
Positive negative.
It's 7 o'clock.
It would be a 0. So we now have the equation 2A is smaller than 2C. It's the same as saying 2 apples is less than 2 peaches. So if you got rid of 1 apple, you got rid of 1 peach, then you just have an apple is less than a peach, right? So we have here inequality that a pear is less than an apple, which is less than a peach. So now the last equation we want to prove is that either an orange is heavier than a peach or a peach is heavier than an orange, right? So now this is where our proof by contradiction comes in. Jason, he already guessed that peaches are the heaviest, right? Just by looking at the system of equations that he guesses that peaches are going to be the heaviest. I'm just going to contradict him and go like, hey, oranges are heavier because oranges, they're spherical, they look nice, so they're heavier, okay? So we're going to assume that oranges are heavier, okay? And if we assume that oranges are heavier, let's take equation 1. We know that A is greater than R, and by our assumption, we assume that oranges are heavier than peaches, right? So if we add them together, what's A plus O? Well, A plus O is just A plus O, right? What about R plus C? R plus C, A plus O would then be greater than R plus C. This is my assumption basically. So I would have A plus O is greater than R plus C.
I have one question.
Yes.
O, just to make sure O weighs more than R, right?
Yeah, we already know that O weighs more than R. We already know that A weighs more than R. And
If here it says O is heavier,
I assume that O is greater than C. And if A is greater than R and O is greater than C, then A plus O is greater than R plus C, right? We can add them together. So it's the same thing as if I said, I weigh heavier than this calculator, and let's say Jason weighs heavier than a pencil. It's the same thing as my weight plus Jason weights is obviously going to be more than a calculator plus a pencil. That's the same logic, right?
more than 100 calculators.
So over here, I assume that an orange weighs more than a peach. Just for the sake of contradiction, okay? And then in the end, I got an apple plus an orange weighs more than a pear plus a peach. But you might go like, hey, even look here, this equation. It says A plus O is equal to R plus C, right? So our initial assumption that an orange weighs more than a peach, that's false. That means I lied again. So in this case, an orange is not, it doesn't weigh more. All right. So in this case, a peach would be the heaviest fruit of them all. Okay. We're not too sure where oranges go, but we just know that peaches, they weigh more than everything. So we have our answer. Just by using proof by contradiction, we found out that indeed C, peaches, they are the heaviest fruit of them all. I know I went a bit over time. Would you guys like to finish the speed round? The speed round, I think we can finish it really, really quickly. So if everyone can wake up again, get back to we're playing the Kahoot. So yes, Kevin, I am aware it's 7 o'clock.
Okay, got it.
Okay, we can finish our Kahoot. This is the speed round. You guys ready? Here we go. Questions are all actually decently challenging, I think. Not this one exactly, but okay. I think everyone knows multiplication. That's good. Next one. Another multiplication problem. Nice. 21 is the answer. It's just 7 plus 7 plus 7, or you can add 3 7 times. Wow. So complicated. Oh. Well.
Oh, it's 0.
It is 0.
Times everything,
everything,
times 0.
all that junk, it doesn't mean anything once you multiply it by 0. So it's just the multiplicative property of 0. Anything times 0 is 0. So that's the answer. All right, we're climbing back up. This one is a bit hard. So I think I'm gonna have to cover this in a later lesson because lots of people seem to have gotten this wrong. Basically, a negative multiplied by a negative.
Negative times a negative. Negative is always positive.
Correct.
No matter what you do, like
no matter what
negative 1 billion times negative 1 would still be a positive.
Yes, it would still be a positive. If it's a negative times a positive, then you guys would be right. It would be a negative number. But if it's two positives, it's obviously a positive. If it's two negatives, then it's a positive. Okay, this is a concept I think we're going to have to go over again sometime. Moving on. Use decimals.
I accidentally clicked something.
Well, this one, you can kind of guess from the answer that it's about 8 point something. It's not 8 itself. It's just 8.8 because 0.5 plus 0.3 is 0.8, so 8.8. I think we have a few more questions left. Let's speed through this. Oh, 3/4 plus 1/6. Okay, I think the timer was a bit tight on that one. Did you guys actually know how to do this, or have
I
you guys?
didn't even get to look at the question.
Basically, you have to find the same numbers like 4
At the
and
bottom.
6